I just wanted to give you a couple hints about the derivatives WebAssign. The first one is really just a math question. F primed of x is the derivative of f of x. So you take the derivative of your function and you enter the numerical values for each of these in the 5 boxes. So that is that. Same thing here. The derivative goes in this place. You can use a caret to tell WebAssign that you're going to write a number as an exponent. Okay, so 3 is where the physics begins. So in number 3 and after are the ones I expect to see in your WebAssign notebook. This is a position function. The first question is asking at what time does the particle momentarily stop. Stop means a velocity of 0. So we're going to start with our position function and then take the derivative to get a velocity function and then treat it for a velocity of 0. Once you know when it stops, part B is asking where it stops. So we have a position function. C and D are asking at what times the particle passes through the origin. The origin is just a way of saying x equals 0. E asks you to graph x versus t for time range. Your instructor, I will let you know, will not ask you to turn in that work. So this is just to, although I will say that if you graph x versus t on your calculator and then modify it with the plus 20t and plus 20t and minus 20t, then it makes this easier. You don't have to guess, you can just play with it. And so yeah, this is just stuff you should try on your graphing calculator. For number 4, we are given again a position function. We want to figure out the average velocity. Now, a lot of times people get confused and go straight for the derivative because it's a position function. That will be a good idea to find the instantaneous velocity for B, C, and D. However, remember, average velocity is defined as displacement over time. So we need to figure out the position at time equals 2, the position at time equals 3, and then use average velocity equals change in position over change in time to calculate your answer to A. Then again, the derivative will be helpful for B, C, D. E is one of the more confusing parts on this WebAssign because it's asking for the instantaneous velocity when the particle is midway between its positions at t equals 2 and t equals 3. Often students think it should be the same answer they got for D, thinking the mid time is what's important, but it's not interested in the midway time, it's interested in the midway position. So the first step is to figure out what that midway position is, and as a hint, you already figured out where it is at t equals 2 and t equals 3 for part A. You can average those two positions to find the midway position, and then you can plug that position into this equation to find when it's at that place. Once you know when it's at the midpoint, then you can use your derivative the same way you did for B, C, and D to figure out how fast it's going at that point. E is the most complicated of any of these, and I'll try to, if you need to check in with me on Monday on that point, I understand. In number 5, it's just a little awkward with these graphs. So the first figure is a position versus time graph with 1, 2, 3, 4 different trends on it. And this one is V versus T with 3 different trends on it. So this equation describes position. A says calculate the average velocity during the first 3 seconds of its motion. Well, again, we know that average velocity is change in position over change in time. B, calculate instantaneous velocity at t equals 3 seconds. Again, we know we can use a derivative to find that. Instantaneous acceleration, well, acceleration is the second derivative of position. And then D, E, and F are asking about the lines on figures A and B. So using figure A, in which the blue parabola is the plot of x versus t, indicate how the average velocity during the first 3 seconds can be obtained graphically. So the blue line is x versus t, and then which of these could represent an average velocity during over a period of time. So again, talk to each other, try to make the sense of these. The wording can be a little confusing. but just try to see how they can relate to these graphs here.